Hello students, in the previous two videos we have discussed about pole placement techniques. That was the only topic which we left over in the unit number 5. So from this video what we are going to do is we are going to revise the topics in our syllabus one by one. The first topic which we are going to revise is block diagram reduction techniques. So in that, first we are going to see what are all the rules for block diagram reduction. Generally in these type of problems you will be given with a complex block diagram of a system and you will be asked to find the overall transfer function by using block diagram reduction rules. There will be some 8 basic rules that we can learn easily, and by using this we can solve the problem of block diagram reduction. The first rule is combining blocks in cascade. Let us consider that two blocks G1 and G2 are in cascade, and in that situation that two blocks can be combined together into a single block with the gain of G1 multiplied by G2. So the net output will not change. The only thing we want to notice while applying the block diagram reduction is whatever the changes you are making in the actual block diagram, that should not affect the actual dynamics of the system. The second rule is combining blocks in parallel, or parallel blocks can also be called as feed forward paths. So the signal is A and the path through G2 is called as feed forward path here. So in that case both the blocks can be combined together into a single block with a gain of G1 plus G2. The third rule is moving a summing point ahead of a block. Ahead of the block means taking the summing point after the block. In that case, in order to retain the dynamics, the signal B is once again multiplied with the gain G and then added with the signal coming from A. Then the fourth rule is moving a summing point before a block. In this case the summing point is after the block G. If we want to move it before the block, then what we want to do is the signal which is taken before the block has to be multiplied by the inverse of the gain. So here the gain is G and the signal B is taken before the block, so we are multiplying the signal with the gain of 1 by G. Then the fifth rule is moving a branch point ahead of a block. So in that case we have a branch point before the block G, and if you want to take it ahead of the block, then it has to be multiplied by a gain of 1 by G. And moving a branch point before the block, it will be a reversal of moving a branch point ahead of a block. So after the block we have a branch point. If you want to take it before the block, then you have to multiply the branch with the gain of G. So in this case the gain is G. In real problems, whatever the block you are taking it before, its gain has to be used. Here comes the important rule for block diagram reduction: eliminating a feedback loop. Here the feedback can be of two types. One is positive feedback and the second one is negative feedback. So here the first shown is a negative feedback loop and the second shown is a positive feedback loop. When there is a negative feedback loop, then that can be combined into a single block as G divided by 1 plus GH. And when there is a positive feedback loop, it can be combined into a single block as G by 1 minus GH. And the eighth rule is swap between two neighboring summing points. When there are two summing points, the first summing point is adding two signals A and B, and the second summing point is adding the signal A plus B and subtracting C. So if you want to interchange these two, then it can be easily done. That what we can do is, first we will subtract A first we will do A minus C, and with that we will add B. So in that way the two summing points can be interchanged or swapped. So these are all the 8 basic rules for block diagram reduction. So in the next video, let us see how we can apply this method to solve a problem. Thank you.